Hey guys, okay, so we are now at adding and subtracting rationals, all right? And I know it looks a little scary, but it's actually not. So as long as you follow the 4 steps to adding and subtracting rationals, you really shouldn't have any problems as to how to solve them. Again, everything that I do on the videos, the anchor charts will be posted up on the wall for you all to see. I recommend again that you take a picture of that and put them in your spirals so that when you take your test, you can continue to use these charts to help you out for solving rationals, okay? All right, so again, we're gonna go ahead and talk about this one right here. This is problem number, I believe it was problem number, where am I? Number 4 on one of the worksheets. You will have 2 worksheets. And this is problem number 4. So the first question you want to ask yourself is, to get started, we are going to say, are denominators the same? Okay, so are denominators the same? And the answer is yes, they are. Yes, they are the same. This one right here has a 3r cubed plus 15r, and this one right here has a 3r cubed plus a 15r. So if they are the same, then you're going to rewrite the expression under one denominator. So we are going to rewrite expression under one denominator. All right, so if I go ahead and I rewrite that expression under one denominator, then I'm going to go ahead and rewrite this expression right here. So I'm going to go ahead and label this number 1 right here so that we could follow what I just did. And I put the 8r plus 3. Because this is a plus, everything above it will stay the same. So plus 6r plus 6 divided by, and these two are the same, so you only write it once. All right, okay. Now, once you have completed this, the next thing you are going to do is you're going to combine like terms in the numerator. So we are going to do step 2, combine like terms in the numerator. So we have 8r plus 3 plus 6r plus 6. Now, my class, remember what I told you guys. To identify your terms, we're going to start off with the highest exponent, which is the r term right here. So this is an 8r. You look around to the other 3 terms and you find out which one else has an r, and that would be the 6r. So then you're like, okay, what's the second set of terms? That would be the positive 3. And the next one that's a constant like it is the positive 6. So now we combine just the lines. So positive 8r plus 6r is 14r. 3 plus 6 is plus 9. Okay? So now we come over here and we're going to rewrite that up again. And when you rewrite it again, you're going to come out with 14r plus 9. And then you're going to divide that by the 3r cubed plus 15r. All right. The next step you're going to ask yourself is, can I factor out the numerator or denominator? Okay? So you're going to ask yourself, can I factor out the numerator denominator? So, 3. Can I factor the numerator and or denominator? And for the numerator, I'm going to label it N for numerator. The answer is no, you can't. For the denominator, yes. So we have 3r cubed plus 15r. So to factor it out, you're going to ask yourself, Well, first of all, let's take a look at the coefficients. What does 3 and 15 have? What do 3 and 15 have in common? And the greatest common factor for 3 and 15 is the 3. So I'm going to take out the 3 because 3 times 1 makes 3 and 3 times 5 makes 15. The other thing is my variable r right here and an r cubed here. So at least there is an r that's in common for both terms. So I do parentheses, so 3r times blank gives me 3r cubed, and that would be r squared plus 5. So r squared plus 5. All right, so now I can go ahead and write that down in the denominator. So I'm going to rewrite this right here. So we're back to step 3. And we write that, what we just wrote, 3r, sorry, that was my bad. I meant to do the 14r, so we rewrite it. So we do 14r plus 9. And that's divided by 3r times r squared plus 5. All right? And the last question that you are going to ask yourself is, can I go any further? Can I reduce it? So let's find out. Can I go any further? The answer is no. So number 4, can I go further? Oh, let's do that in blue. Do not need to do that in green. Yes, that was a bell in the video, not the class bell, so do not get up and leave. All right? I'm watching you all. Okay, so number 4 is, can I go further? So can I reduce? And the answer is no. So number 3 is your final answer. So I just circled the square and put a square around that. So there it is. That is adding rationals. All right. All right, so let's take it a step further now this time, and let's talk about this next problem. I believe this next problem is let me double check it. I believe it was problem number 5 on the worksheet. This is problem number 5 on the worksheet. All right, so number 5 is a little bit more complicated. Now, it's not too bad, like it's not too complicated, but you know, it's okay. So here's what we're gonna do. The first question you need to ask yourself is, are the denominators the same? So we're gonna ask ourselves, are the denominators the same? So number 1, are denominators the same? And the answer is no. Okay, now, because the denominators are not the same, you need to get the common denominator for each one. Okay, so if you look at here, and you look at here, you're looking at these, and you're going to look at this. So the first thing we need to know is the denominator 4 must be multiplied by 3. So 4 must be multiplied by 4p plus 3. So this denominator 4 must be multiplied by this 4p plus 3. And 4p plus 3 must be multiplied by 4. So this must be multiplied by 4. And the last thing you need to remember is what you do in the denominator has to be done in the numerator. So what you do in the denominator must be done in numerator. All right, so let's go ahead and get this one started. So I'm going to go ahead and rewrite this as number 1. Okay. Let me go ahead and put this down really quick. Give me 1 second. 7p divided by 4 right, so I'm going to go ahead and multiply this left side by 4p plus 3. So I'm going to multiply this by 4p plus 3, and this by 4p plus 3. And then this is going to be times 4 and times 4. All right. Now, what I do next is I am going to distribute. So the next thing I'm going to do is I am going to distribute in numerators only. Don't mess, because remember, okay, do not mess with the denominator up to this point right now, because we are trying to simplify these, and we're trying to simplify these expressions. And so we're going to have to either factor out or take the GCF. Since the denominators are already in parentheses already, we don't have to worry about multiplying that. The only thing we need to distribute first are the top ones, okay? So step 2, distribute numerators only. Okay? So if I distribute the numerators only, we're going to go ahead and write this as number 2. And we're going to write this back down. Let me go ahead and do this really quick, set this up. I know it looks a little redundant, but if I go step by step for you guys, I know for a fact that you guys will be okay. And I'm just trying to help you all out in this point. Okay, so when I talk about distributing, all I'm talking about is this 7p, you need to multiply to the 4p, and it also needs to be multiplied to the to the 3p. So 7p times 4p is 28p squared. 3 times 7p is plus 21p. Okay, and that's divided by, and then I'm just going to put this here, 4 times 4p plus 3. Notice the order right here doesn't really matter, so don't worry about that. Minus 4 times 2p is 8p, and 4 times 2 is plus 8, and that's divided by, and I'm going to put the 4 up front, times 4p plus 3. Notice how I put the bottom and I changed this up right here? It's still the same thing, so don't worry about that. Okay? All right, so the next thing, step 3, I want to see what you guys think I should do for step 3. Let me hear you say it. Let me hear you say it. Yes, exactly. You're going to put everything all under one denominator. God, you guys are so smart. Just so you know. I'm pretty sure somebody thought it on the other video. I mean, on the other side of the... Forget it. Just forget it, guys. All right, so we are going to put all terms under one denominator. Put all terms under one denominator. All right, so here we go. Step 3. We have 28p squared plus 21p. Now, here's the part where you need to see this. Recall from the last cycle when I told you guys, whenever you have that minus sign, it changes everything after that. So you see this minus? It's minus 8p, minus 8. Change the signs. On the other problem, the one with the addition, we didn't change the signs because they were addition. In this case, this is going to change this right away. So I could have, and I'm going to go back to the original problem, I could have taken this, and I could have changed that to a minus 2p, and this would have turned to a minus 2. So I want you to see what I just did there. So that becomes minus 8p minus 8, and that's all divided by 4 times 4p plus 3. And then number 4, combine like terms in the numerator. So number 4, we're going to combine like terms, and we're going to put that in the numerator. So 4, combine like terms. in numerator. All right, so if I'm going to combine like terms in the numerator, we're going to put the 28p squared. So I have the 28p squared plus 21p minus 8p minus 8. So this is one term, this is two terms, and this is three terms. So your final answer is still going to have three terms. So when I get that, then I end up with 28p squared plus 13p minus 8. So if I come over here to 4, I write 28p squared plus 13p minus 8 divided by 4 times 4p plus 3. Okay. And then number 5 is going to ask a question. And number 5 says, can I factor the numerator? So number 5 says, can I factor out the numerator? Can I factor out numerator? All right. The answer is no. All right. Please see the chart that says subtracting rationals, and you will see it. And we went ahead and we put the factors for 28p squared plus 13p minus 8, and we found out that none of those factors work to get me what I need to get to. So the answer is no. So step 4, so 4 is your final answer. All right, so that is how you add and subtract rationals. I only gave you 2 examples because really that's what you need to know. That's the hardest as it's going to get. You already by now should know how to factor, so if you come across the point where you need to factor them, you're going to have to factor them. But most of it is just finding GCFs anyway as well. So if you have any questions, you can go ahead and come to tutorials if you need help, or also you can ask Ms. Oviedo, of course, for help as well, or Ms. Blake as well for any kind of assistance. All right, so there we go.